So hello everyone, welcome back to our channel. So today's last question, and our question is implementation of LRU cache. So before knowing this question, we have must understand the concept of doubly linked list and map data structure. So coming upon the question, what question says? Question says we have to implement some functions of LRU. LRU stands for uh, least recently used, means we will be using some linked list nodes and the map data structure to store the node and their address, and we will be updating them in some functionalities, like we have a fixed capacity of size of elements, and we will be writing the function to get the element and to put the element in our linked list, etc. So LRU cache is initialized with the capacity that we have a fixed number of capacity of elements in our LRU cache, and we have also a get function that contains the key, and it will return the value of the key if the key exists, and if the key not exists, simply return -1. And with this we have also a function that is void put function that contains a key and a value, and we will be updating value of key if key exists, and if it does not exist then we will be creating a new value, or we will be adding a key value pair to our cache. So these are three major functionalities what we have to do. If number of key exceed the capacity, in that case we will be deleting our LRU, means least recently used node, and after removing that node we will be adding our new coming node that with its key and its value. So these are the different tasks. So let's take an example where we have some functionalities. So our first functionality is to make a LRU cache of size 4, and put elements like put 2,6, put 4,7, put 8,7, 8,11, and put 7,10. And after that we have to get 2 and get 8. Then we have to again put 5,6 and then put 5,6, get 7, and in the end put 5,7. So these are different questions that we will be implementing in our LRU cache question, and we will be writing some functions and class according to our given question. So there will be different condition. Let's discuss that. All condition will be covered in this example within the self. So for the first, we will be creating a LRU cache of size 4, means we will be creating a LRU, least recently used cache memory of size 4, and we will be maintaining it in a doubly linked list form, and also storing our key along with its address node in our map to find the key, and we will be implementing it. So now firstly put 2,6 as our LRU have capacity of 4 and initially we have 0 elements. So we will simply put it in our linked list and create a node. Then again put 4,7, again create the node, and LRU's least recently used will be in on the to the head side, and head and LRU element means the firstly element that used was in the tail side, or tail dot previous will be the first node, that is 2,6, and after that 4,7 encounters. So we will be putting 4,7 uh, before tails previous dot previous value. So in this format we will be putting new upcoming nodes and updating in the question. So head next will be our LRU's latestly used element, while the first element that was firstly encountered was on the tail side. So coming upon 7 comma 10, we will be adding that note also, and now gets the function get 2. So we will be checking our LRU map data structure where we will be matching it as we have a value of key value of 2 if 2 exists. So yeah, we get it, and we have the two value. 2 comma 6 is the value. So in this case we will be returning the 6 value, and along with this, now we will be updating our LRU operation, and firstly 2 comma 6 node will be deleted from that node, and it will be moved, or a new node will be created on the head side, and 2 comma 6 will be deleted from the tail side firstly. So to store it in a minimal storage, or to make it much optimized, we will be just changing the nodes. In our linked list journey we have already learned about the changing of nodes and deletion and insertion of nodes, so we will not be discussing that part. But yeah, we can understand it that we are just shifting the nodes next and previous values, and we are not we are not deleting the node itself. We are just changing their link to make it looks like that we have deleted from there and updated on our head side. So after this we will get get 8 function, and as 8 function is also present as 8 comma 11, so again we will be updating our value, and 8 comma 11 node will be deleted from itself, and will be updated on the head sides. The head dot next element will be as 8 comma 11. Now next node is 5 comma 6, so we does not contain any 5 comma 6 node, thus we will be creating a new node of 5 comma 6 on the head side, and after that get 7. So yeah, we have 7 on our node, that is 7 comma 10, so we will be returning the 10 and updating our LRU, and 7 comma 10 node will be deleted from that itself point, and a new node will be added on the head dot next side, and in the end we have 5 comma 7. So we will be checking, does we have the 5 value? Yeah, we have 5 comma 6 in our LRU node linked list, and we will be updating 5 comma 6 value as 5 comma 7. So for that, firstly we will updating our LRU node position. So 5 comma 6 will be deleted from that point, and it will updated on head dot next node, and after that we will be updating a 5 comma 6 value, and along with these operation, whenever we are updating the values, we are just maintaining a record in our map data structure. Map will contain two different values. It contains the key and the node. Node is specifically the address where our key is stored, and we can identify it by that address. So these are the basic functionality that we will be doing. We will be writing some function like deletion of node that contains the node itself, and insertion after the head, because we are updating our new values, and after the head or head dot next value node is updated. So we will be writing those function, and along with that, let's come we will be creating a class of LRU that contains the map, and map contains our node and value, and along with this the capacity, head and tail will also be updated. Firstly we will be taking tail dot next is equal to, no, head dot next is equals to tail, and tail dot next is equal to tail dot previous equals to head, and both next and previous will be previous and next will be null, uh, accordingly that order. And now we will be taking a LRU cache capacity, where we will be taking capacity, and if we do, as our map is clear, so we will be firstly clearing our map data structure, map dot clear function, and head next is equals to tail, and tail previous equals to head, that I have discussed. So after this we will be checking for the get function. So we will be taking a function int get that contains the key value, and we will be checking if our map has key. So we will be write a function for map has key, checking the condition, does it contain the key or not. In our map data structure we will be find that value by using map.find.begin to end. We will be check, if it does not contain then return -1, and if it contains then our new node will be created, because we have find out the value. So for getting the function, node will be created of maps key value, and we will be delete our current node, and after that we will be inserting the new head node, head dot next value, at the head dot next value. Now coming upon the void put function, where we will be taking a key and a value, and if map has key, if it contains the key, so we will be taking a new map value in our node, and node value is equals to value, means we are just updating the value that was in our example of 5 comma 7, that we have 5 comma 6 already present in our linked list, and we have updated it firstly in our LRU positioning, and after that we will be updating that value. So nodes value is equals to value, and after that we will be deleting our previous node and updating it on the head dot next. So insert after head function will be called off, and if it is not the case, means we are not updating any value, so what we will be check, we will be check if does our capacity, does it comes in our capacity or not. There is also a case like for previously there were four different nodes arranging one after another, and now a fifth node encounter, but we have a capacity of four elements only in our linked list, so that we cannot put it in our linked list. Thus we will be deleting our tail dot previous node firstly, and then updating LRU's head dot next value by this node that is coming. So for this we will be checking if our map size is equals to capacity, so we will no, our node will be tail previous, we will be erasing that node, and after that deletion of that node will be occur, and we will be check if our then we will be updating new node by key and value and updating it in our map data structure, because we have to update and take the record of that value and their address, their key and their address in our map, so that after onwards we will find it, so we are able to check it on our map also. So we will be updated in our map, and after that we will insert it after the head. So this is the overall functionality. Let's discuss the functions of delete node after head, and insert after head, and deletion of node. So for the deletion of node, we are just changing the links in our previous linked list journey. We always know, we along with that know that we have to change the links only. So our previous node will be nodes previous, and after node will be nodes next, and after that our previous nodes next will be updated by after node, and after nodes previous will be updated by previous node, and this is the deletion function. And now node that will be inserting just after the head will be written as we will be taking a head, that is head dot next, and that current after head will be head dot text, and head next is will be our new node, and node next will be current head, and node previous will be our head. So this is the after node functionality. So that's how we will be able to do the LRU operations, means least recently used operations. In this journey we are just checking and updating our head dot next element, and also updating our or deleting or erasing the elements that are tail's previous element, because in LRU we will be from head to tail side, we are moving in a LRU format, and whichever will be used recently will be updated on the head side, and whichever will be the lastly used element will be present on our tail side. So this is overall functionality of LRU operations that we will have completed by making some class and some different operations. Hope I think that you understand the concept and question. And with this, our stack and queue journey ends here. And it is so exciting to tell that now we have completed all the concept of stack and queue. Now we will be practicing the stack and queue questions over lead code and different platform. And with this we will be taking a 10-day sprint challenge, where we will be solving these questions, whatever be the concept we have learned throughout the journey, we will be trying to do their optimal solution, their brute force solution, and better solution, of course. And hope that these 10 to 15 days will cover all the concept and made us do practice more over stack and queue, and eventually give us the good hand hold over this concept. And after that we will be starting a new data structure concept in our journey. Until that, stay tuned, stay happy. Thanks, have a nice day.